So here in this video again we'll continue solving the problems based on Laplace equation. In the previous video I told you to do this problem as a homework, right? Which was v equal to x square minus 3y square plus z square. Just follow the same procedure what you have done, and we just have to find out the whether it is equal to 0 or not, whether the result is equal to 0 or not. Okay, so now we'll do the next problem here. That is, the field of a region in space is given by the equation E. You have to check whether the region is free of charge. Okay, they're asking to verify whether the region is free of charge. Now we just see there is a difference in this problem compared to the other problems which you have seen just now. In all the problems, they've given you the potential value, right? Because Laplace equation is del square V equal to 0. You need potential to apply Laplace equation. But here they've given you intensity. Okay, so directly I cannot get del square V from this. So what you have to do is use the relation between E and V. Okay, that is E is equal to minus del V. So you have to use this relation to get the Laplace equation. Okay, so that you will be able to find whether it is 0 or not. Okay, so here we'll use this gradient relation. Minus del V is equal to E. I'll take the minus to the other side. So del V becomes equal to minus E. Now let's multiply or take dot product of del on both the sides. Okay, so I'll take one more del on this side and also the same thing on the other side. Okay, del into del V and del into E. So del into del V is nothing but del square V, and here you have minus del dot E. Right? So here del square V is nothing but the Laplace equation. If this value becomes 0, I can say that it is satisfying the Laplace equation. So here del square V cannot be calculated directly because V is not given. But instead of del square V, we can calculate minus del E because E is given in the question, right? And del is nothing but a divergence operator, which is dou by dou x ax plus dou by ay plus dou by dou z az. You have seen this in the previous module, okay? And here the system is, we can assume it to be Cartesian system, okay? Or in general, you just see this is your divergence. Del is nothing but divergence operation, which is given by this equation dou by dou x ax, dou by dou y ay, dou by dou z az. Take dot product of this and the given intensity equation. So you just have to take now del dot E. So dou by dou x ax plus dou by dou y ay plus dou by dou z az. This and the intensity equation 5 cos z az. Dot product of these two. Okay, and according to the property of dot product, we know that any two vectors of opposite direction, different directions, sorry, ax dot az will be 0, ay dot az is also 0, whereas az dot az will give you value as 1. So these two terms will not come into picture. You will be having only the third term here. So you are getting the answer as dou by dou z of 5 cos z. Az into az is 1. Okay. So what is the answer now? You have this 5. Differentiation of cos z with respect to z will be minus sin z. And here you already have a negative sign, right? Minus del E. So if I put minus here, you'll get minus again. Here minus. So the final answer is going to be 5 sin z. Right? So del square V was nothing but minus del dot E. And the answer I'm getting is 5 sin z, which is not equal to 0. You can see that del square V value, whatever you're getting, is not equal to 0. So if it is not equal to 0, it means it does not satisfy Laplace equation. If you remember the derivation part, you people had this, right? Del square V is equal to minus rho V by epsilon. That is your Poisson's equation. And from this we obtained the Laplace equation. So what was the assumption that we did? We assumed that we have a region where there is no charge present. If the charge is not present, then the volume charge density becomes 0, and that is how we are going to get the Laplace equation, right? But here in this problem, you're getting something else other than 0, which means that the assumption that there is no charge, it is not valid here. So we can say that the region is not charge free. Okay, this particular region does consist a charge which is not equal to 0. It is not a charge free region. It is a region where there is a charge present in it. That's why we are not able to satisfy the Laplace equation. Okay. So the question was, they have given you the intensity and they were asking whether this region is free of charge. But you found out that by using all this substitution and simplification, you found out that the region, the value of this del square V is not 0, which indicates that the region is not charge free. Okay. So that should be your conclusion. You should say that the region is not charge free. I hope you have understood this problem. Okay. So we'll move on to the next question. Determine whether or not the potential equations, two questions are there, satisfy Laplace equation. This is similar to your first problem, okay? The first equation is given in Cartesian system. So use the Cartesian coordinate equation and solve it. And check whether you're getting the answer as 0 or not. Similarly, this will be in spherical coordinate system. You have to simplify it and get the result. Okay. So you can pause the video and you can solve these two problems. Then the fifth question is also exactly the same as this. The equation is given. This is 2x square minus 3y square plus z square. Another one is r square plus z square. If r and z is given, it is cylindrical system. Okay. This is Cartesian system. So similarly solve these two problems and verify whether it satisfies the equation or not. Right? You can again pause the video, you can solve it. So coming to the last question now, under this category, they've given the potential field V, and the first part, they're asking you to find the unknown value K, given the condition that it is already satisfying the Laplace equation. Okay, so we'll solve this first one. Del square V equal to 0. They have told that this particular equation satisfies Laplace equation, which means the differentiation of this, the Laplace of this should be equal to 0. Okay. This is Cartesian system here. So the equation will be dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square. That is equal to 0. It's already mentioned that it is equal to 0. Okay. So individually we'll try to find out these three terms, add it, equate it to 0, and then we'll see how to simplify it further. So first we'll find this dou square V by dou x square term. What is the V value given here? 3x square yz plus ky cube z. So partial differentiation with respect to x. So this term acts as constant, which can be the differentiation of which will give you 0. So you'll be having only the first term x square, so it becomes 6xyz. Okay, and again differentiation will give you 6yz. Similarly, the second component, so dou by dou by of dou by dou by 3x square yz plus ky cube z. The first term differentiation will give you the answer as 3x square z, and the third will give you 3ky square z. And again, if you differentiate, the first term becomes 0, and the second term will become 6ky z. Okay, and now the last term, dou by dou z, dou v by dou z. So dou by dou z of dou by dou z. This is 3x square yz plus ky cube z. So first term will be 3x square y. Second term will be ky cube. And again, if you differentiate, it does not have any z term, so it becomes 0. So you got the three answers here. First one was 6yz, second is 6kyz, third one was 0. All of them added together and equated to 0. Okay, so now we can say that, can I just take like this, 6kyz on the same side and 6yz can go to the other side. So it becomes minus 6yz. So 6yz on both the sides get cancelled and you will find out that k value is equal to minus 1. So this is how we solve for the first part. They've already mentioned that it is satisfying Laplace equation. So the Laplace del square V should be equated to 0. Whatever result you're getting, you just equate it to 0 and you can find out the unknown value. Okay. So this is how you solve the first part of the problem. Now coming to the second question, they're asking you to find E value at certain points. Okay. So you should know the relation between E and V, which is minus del V, right? And del is nothing but your divergence operator, which is dou by dou x ax. You can keep this minus outside, plus dou by dou y ay plus dou by dou z az. Now this is multiplied with v value. Okay, so if I open bracket and multiply, it becomes dou v by dou x ax plus dou v by dou y ay plus dou v by dou z az. Okay, a common minus sign outside. So now individually we'll do this operation, minus within the bracket dou by dou x of v. V is 3x square yz plus, you found out the k value as minus 1, no? You can substitute that value in the above equation. So here you had k y cube z. So k can be replaced as minus 1. So you will be getting minus y cube z in ax direction. Similarly for the second term, 3x square yz minus y cube z in ay direction. And then last term, 3x square yz minus y cube z in az direction. So the result will be now differentiate with respect to x once. So this becomes 6xyz. This is 0 ax. And here you have 3x square z minus 3y square z in ay direction, plus for the last term it will be 3x square y minus y cube in az direction. They've given some points, right? They have mentioned you're supposed to find E at points 1, 2 and 3. Right? The points are 1, 2 and 3. That is nothing but x, y and z values are given. So you just have to substitute those values for x, y, z. So x, 6 into x is 1, y is 2, z is 3. Next term, 3 into x is 1 square, z is 3, minus 3 into y is 2 square into 3. Okay, this into ay, plus 3 into 1 square into 2 minus 2 cube in az direction. So if you just simplify all this, the final answer you're going to get is minus 36 ax. You have a minus sign common outside, okay, because of this. Remember that. So minus 36 ax plus 27 ay plus 2 az volt per meter. This should be your answer. Minus 36 ax plus 27 ay plus 2 az volt per meter. Okay. So this is how you would solve the solve such problems. If v is given and if they ask you to find e, you have to use this relation. E is equal to minus del v. These are some simple problems under Laplace equation. So in the next video, we'll be seeing about one more derivation, that is uniqueness theorem. With that, the derivations will be done in this. Only two are there. And then we'll see some problems again based on that. Okay.